Poisson distribution. Poisson distribution is a limiting form of binomial distribution when the probability of success in each trial is very small, that is p tends to 0, and the number of trial is very large, that is, n tends to infinity. So that np equals lambda, constant. Definition: a discrete random variable x is said to follow a Poisson distribution with parameter lambda greater than 0, if its probability mass function is given by p of x equals e power minus lambda into lambda power x divided by x factorial, where x equals 0, 1, 2, extra. Then x is said to follow a Poisson distribution with parameter lambda. Mean and variance. Moment generating function. mx of t equals e power lambda into e power t minus 1. Differentiating with respect to t, we get mx dash of t equals e power lambda into e power t minus 1 into lambda e power t, equation number 1. Put t equals 0, we get mx dash of 0 equals lambda. Therefore mean equals lambda. Again differentiating equation 1, w.r.tot, we get mx double dash of t equals lambda into e power lambda into e power t minus 1 plus e power lambda into e power t minus 1 into lambda e power t. Put t equals 0. We get mx double dash of 0 equals lambda into 1 plus lambda. Hence variance equals mu2 dash minus mu1 dash square equals lambda. Since mu2 dash equals mx double dash of 0, mu1 dash equals mx dash of 0. Moment generating function. mx of t equals e of e power tx equals summation over x equals 0 to infinity e power t x. P of x equals summation over x equals 0 to infinity e power t x e power minus lambda into lambda power x divided by x factorial equals e power minus lambda summation over x equals 0 to infinity lambda e power r whole power x divided by x factorial equals e power minus lambda into 1 plus lambda e power t by 1 factorial plus lambda e power t whole square by 2 plus extra equals e power lambda into e power t minus 1. Mean and variance. Moment generating function. mx of t equals e power lambda into e power t minus 1. Differentiating with respect to t, we get mx dash of t equals e power lambda into e power t minus 1 into lambda e power t, equation number 1. Put t equals 0, we get mx dash of 0 equals lambda. Therefore mean equals lambda. Again differentiating equation 1, w.r.tot, we get mx double dash of t equals lambda into e power lambda into e power t minus 1 plus e power lambda into e power t minus 1 into lambda e power t. Put t equals 0. We get mx double dash of 0 equals lambda into 1 plus lambda. Hence variance equals mu2 dash minus mu1 dash square equals lambda. Since mu2 dash equals mx double dash of 0, mu1 dash equals mx dash of 0. Problem 1. Suppose that x has a Poisson distribution if p of x equals 2 by 3 into p of x equals 1. Evaluate 1. P of x equals 0, 2. P of x equals 3. Solution. We know that e power minus lambda into lambda power x divided by x factorial x equals 0, 1, 2 extra. Given P of x equals 2 by 3 into P of x equals 1. Implies e power minus lambda into lambda square by 2 factorial equals e power minus lambda by lambda power 1 by 1 factorial. Implies lambda equals 4 by 3 or 1.3333. I, P of x equals 0 equals e power minus lambda by lambda power 0 by 0 factorial equals e power minus 1.3333 is equal to 0.2637. 2. P of x equals 3 equals e power minus lambda by lambda power 3 by 3 factorial equals e power minus 1.3333 into 1.3333 power 3 by 3 factorial equals 0.104. Problem 2. If x is Poisson random variable such that P of x equals 2 equals 9 into P of x equals 4 plus 90 into P of x equals 6. Find the variance. Solution. Given P of x equals 2 equals 9 into P of x equals 4 plus 90 into P of x equals 6. Implies that e power minus lambda into lambda square by 2 factorial equals 9 e power minus lambda into lambda power 4 by 4 factorial plus 90 e power minus lambda into lambda power 6 by 6 factorial divided by e power minus lambda into lambda square, we get 1 by 2 factorial equals 9 into lambda square by 4 factorial plus 90 into lambda power 4 by 6 factorial. Implies lambda power 4 plus 3 into lambda square minus 4 is equal to 0. Put lambda square equals t, we get t square 2 plus 3t minus 4 is equal to 0. Implies that t plus 4 into t minus 1 is equal to 0. Implies t equals minus 4, 1. Therefore lambda square equals minus 4, 1. Implies lambda equals plus or minus 2i, plus or minus 1. Hence variance equals 1. Problem 3. The number of accidents in a year to taxi driver in a city follow a Poisson distribution with mean equal to 3. Out of 1,000 taxi drivers, find approximately the number of drives with I, no accident in a year, 2, more than 3 accidents in a year. Solution. Let x denotes the number of accidents. Given n equals 1,000, lambda equals 3. We know that P of x equals e power minus lambda into lambda power x divided by x factorial. I, P of no accidents in a year tongue poking smiley of x equals 0 equals e power minus 3 into 3 power 0 by 0 factorial equals 0.0498. Therefore out of 1,000 taxi drivers, the number of drivers with no accidents in a year equals 1,000 into 0.0498 is equal to 49.8 approximately 50. 2. P of more than 3 accident in a year, tongue sticking out of x greater than 3 is equal to 1 minus P of x less than or equal to 3. Equals 1 minus of P of x equals 0 plus P of x equals 1 plus P of x equals 2 plus P of x equals 3. Equals 1 minus e power minus 3 into 1 plus 3 plus 9 by 2 plus 27 by 6 is equal to 1 minus 0.6472 is equal to 0.3528. Therefore out of 1,000 taxi drivers, the number of drivers with more than 3 accidents in a year equals 1,000 into 0.3528 is equal to 352.8 approximately 353. Problem 4. 20% of the bolts produced in a factory are found to be defective. Find the probability that in a sample of 10 bolts chosen at random, exactly 2 will be defective using Poisson distribution. Solution. Let X denotes the number of defectives and P be the probability that the bolts are defective. Given P equals 20% and N equals 10. Therefore lambda equals NP equals 2. We know that P of X equals e power minus lambda into lambda power X divided by X factorial. Implies that P of X equals 2 equals e power minus 2 into 2 square by 2 factorial equals 0.2707. Problem 5. The number of monthly breakdowns of a computer is a random variable raving a Poisson distribution with mean equal to 1.8. Find the probability that this computer will function for a month, I, without a breakdown, 2, with only one breakdown, and 3, with at least one breakdown. Solution. Let X denote the number of breakdowns of the computer. X follows a Poisson distribution with parameter lambda. We know that P of X equals e power minus lambda into lambda power X divided by X factorial. P of X equals 0 equals e power minus 1.8 is equal to 0.1653. 2. P of X equals 1 equals e power minus 1.8 into 1.8 is equal to 0.2975. 3. P of X greater or equal to 1 is equal to 1 minus P of X equals 0 equals 1 minus 0.1653 is equal to 0.8347. Problem 6. A car hire firm has 2 cars which it hires out day by day. The number of demands for a car on each day is distributed as Poisson variate with 1.5. Calculate the proportion of days on which I, neither car is used and 2, some demand is refused. Solution. X denote the number of demands. 1. P of X equals 0 equals e power minus 1.5 is equal to 0.2231. 2. P of X greater than 2 is equal to 1 minus P of X less than 2 since demand is greater than available 2 cars. P of X greater than 2 equals 1 minus of P of X equals 0 plus P of X equals 1 plus P of X equals 2. Equals 1 minus of e minus 1.5 plus e minus 1.5 into 1.5 by 1 factorial minus 1.5 1.5 square 2 by 2 factorial equals 0.19126. Problem 7. It is known that the probability of an item produced by a certain machine will be defective is 0.05. If the produced items are sent to the market in packets of 20, find the number of packets containing at least, exactly and at most 2 defective items in a consignment of 1,000 packets using I, binomial distribution, 2, Poisson approximation to binomial distribution. Solution. I, binomial distribution. Let X denote the number of defectives and P be the probability that an item is defective. Therefore P equals 0.05 and Q equals 0.95. P of X equals NCX P power X Q power N minus X equals 20 CX 0.05 power X 0.95 power N minus X. A. P of getting at least 2 defectives tongue poking smiley of X greater than 2. P of X greater than 2 is equal to 1 minus P of X less than 2. Equals 1 minus of P of X equals 0 plus P of X equals 1. Equals 1 minus of 20 C0. 0.05 power 0. 0.95 power 20 minus 0 plus 20 C 1.0.05 power 1. 0.95 power 20 minus 1 equals 1 minus of 0.95 power 0.20 plus 20 C 1. 0.05. 0.95 power 19 equals 1 minus of 0.3585 plus 0.3774 is equal to 0.2641. Therefore, number of packets containing at least 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.264 is equal to 264.1, approximately 264 packets. B. P of getting exactly 2 defectives. Tongue sticking out of x equals 2 equals 20 C2. 0.05 power 2. 0.95 power 20 minus 2 is equal to 0.1887. Therefore, number of packets containing exactly 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.1887 is equal to 188.7, approximately 189 packets. C. P of at most 2 defectives. Tongue poking smiley of x less than or equal to 2. Tongue sticking out of x equals 0 plus p of x equals 1 plus p of x equals 2 equals 0.3585 plus 0.3774 plus 0.1887 equals 0.9246. Therefore, number of packets containing at most 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.9246 equals 924.6, approximately 925 packets. 2. Poisson distribution. Binomial distribution may be approximated by Poisson distribution with parameter lambda equals np. That is, lambda equals 20 into 0.05 is equal to 1. We know that p of x equals e power minus lambda into lambda power x divided by x factorial. A. P of getting at least 2 defectives. Tongue poking smiley of x greater than or equal to 2. P of x greater than or equal to 2 is equal to 1 minus p of x less than 2. Equals 1 minus of p of x equals 0 plus p of x equals 1. Equals 1 minus of e power minus 1.1 power 0 by 0 factorial power minus 1 power 1 by 1 factorial. Equals 1 minus of e power minus 1 plus e power minus 1 is equal to 0.2642. Therefore, number of packets containing at least 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.2642 is equal to 264.2, approximately 264 packets. B. P of getting exactly 2 defectives. Tongue sticking out of x equals 2 equals e power minus 1.1 square by 2 factorial equals 0.1839. Therefore, number of packets containing exactly 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.1839 is equal to 183.9, approximately 184 packets. C. P of at most 2 defectives. tongue sticking out of x less than or equal to 2 tongue poking smiley of x equals 0 plus p of x equals 1 plus p of x equals 2 equals e power minus 1 plus e power minus 1 plus e minus minus 1 by 2 factorial equals 0.9197. Therefore, number of packets containing at most 2 defective items in a consignment of 1000 packets equals n into p of x equals 1000 into 0.9197 is equal to 919.7, approximately 920 packets. Problem 8. If the moment generating function, MGF, of a discrete random variable x is e power 4 into e power t minus 1, find p of x equals mu plus sigma, where mu and sigma are the mean and SD respectively. Solution. We know that mx of t equals e power lambda into e power t, 1 equation 2. Given mx of t equals e power 4 into e power t, 1 equation 3. Comparing equation 2 and 3, we get lambda equals 4. In Poisson distribution, mean equals variance equals lambda. That is, mu equals lambda and sigma equals sqrt root of lambda. Therefore, p of x equals mu plus sigma, tongue poking smiley of x equals 4 plus 2 tongue poking smiley of x equals 6 equals e power minus 4 into 4 power 6 by 6 factorial equals 0.1041. Problem 9. A manufacturer of cotton pins knows that 5% of his product is defective. If he sells cotton pins in boxes of 100 and guarantees that not more than 10 pins will be defective, what is the approximate probability that a box will fail to meet the guaranteed quality? Solution. Let x denote the number of defective pins. Given p equals 5%, n equals 100. Therefore, lambda equals np implies that lambda equals 5. Hence, probability that a box will fail to meet the guaranteed quality is p of x greater than 10 equals 1, p of x less than 10 equals 1, summation x equals 0 to 10 e power minus 5 into 5 power x by x factorial. Problem 10. 6 coins are tossed 6,400 times. Using Poisson distribution, what is the approximate probability of getting 6 heads 10 times? Solution. Let x denote the number of heads. Given n equals 6,400. Probability of getting 1 head with 1 coin equals 1 by 2. Probability of getting 1 head with 6 coin equals 1 by 2 whole power 6. Therefore, lambda equals np equals 6,400 into 1 by 2 whole power 6 is equal to 100. P of getting 6 heads in 100 times equals e power minus 100 into 100 power 10 by 10 factorial. Problem 11. The mistake committed by a typist follow a Poisson distribution, which is given below. Find the expected frequencies. Number of mistakes 0, 1, 2, 3, 4, 5. Number of pages 1, 4, 2, 1, 5, 6, 6, 9, 2, 7, 1. Solution. Let x follows Poisson distribution with parameters lambda. Capital N equals total frequency equals 400. First, we have to find mean. In the first column x value, second column f value, and third column fx. X value 0, 1, 2, 3, 4, 5. F value 1, 4, 2, 1, 5, 6, 6, 9, 2, 7, 1. Fx value 0, 1, 5, 6, 1, 3, 8, 8, 1, 2, 0, 5. Total 400. Mean equals summation fx by summation f equals 400 by 400 is equal to 1. Therefore lambda equals 1. The theoretical frequency is given by n into p of x equals x. In first column x value, second column p of x equals x, third column n into p of x equals x, and the last column expected frequencies. In fourth column round off value instead of third column. X p of x equals e power lambda into lambda power x by x factorial equals e power 1 by x factorial 400 into p of x equals x expected frequencies. 0 p of x equals 0 equals e power minus 1 by 0 factorial equals 0.3679 400 into 0.3679 is equal to 147.16 147. 1 p of x equals 1 equals e power minus 1 by 1 factorial equals 0.3679 400 into 0.3679 is equal to 147.16 147. 2 p of x equals 2 equals e power minus 1 by 2 factorial equals 0.18395 400 into 0.18395 is equal to 73.5874. 3 p of x equals 3 equals e power minus 1 by 3 factorial equals 0.0613 400 into 0.0613 is equal to 24.5225. 4 p of x equals 4 equals e power minus 1 by 4 factorial equals 0.0153 400 into 0.0153 is equal to 6.126. 5 p of x equals 5 equals e power minus 1 by 5 factorial equals 0.00307 400 into 0.00307 is equal to 1.241.